Alrighty. So let's see how long I do this one. Hard, same as yesterday's, let's say, which was a medium that I kind of did not do. Alright, you give them two integers, num1, num2, representing an inclusive range, num1 to num2, inclusive. The waviness of the number is defined as the total count of peaks and valleys. A digit is peak if it's strictly greater than both of its immediate neighbors. A digit is valley if it's strictly less. First and last digits cannot be either because they don't have two neighbors. Any number with fewer than 3 digits has a waviness of 0 because there's no middle number. And return the total number waviness of all numbers. So yeah, I did yesterday's, but I don't think I can even, I'm not even bother trying to work off of it because it definitely did not do 10 to the 15th. It was like O of n. This thing is strictly like, this thing needs to be O of log n or O of 1. So first off, I'm not sure if I put much thought into it, but like first thing that comes to mind is I should have maybe tried, if you're trying to find like the number of digits, or number, the count of like waves in kind of num1 to num2. I want to say this should be the same as count of waves from like 1 to num2 minus the count of waves from 1 to num1, or maybe nums1 minus 1. And then so this means that you can just define function to find kind of waves from 1 to some number x instead of finding some between some intermediate range. We'll simplify some calculations, I think, hopefully. So there should be like a formula. I mean, pretty much has to be a simple formula. Or O of n, where n is the number of digits, which is the same thing as O of log n, where n is the maximum values. Okay, so let's think about this. Let's actually think about this. So if I think about all, like, let's say two-digit numbers. So, what is count of waves for all two-digit numbers? Okay, actually it's 0, right? Because you can't actually have a wave with 2 digits. Let's say 3-digit numbers. So if you start with 1, there's like, if it's just a single peak, there's 9 numbers that are higher than it, and so if it's 1, then there's 9 numbers that are higher than it, and then for each of those numbers there's like one less than that number that's smaller than it. So like 2, no, actually it's the same number. So 1, 2, and then it can go down to 1, 0. 1 to 3 can go down to 2, 1, 0. So it's a repetition of that number. So 1, 2, has 2, 1, 3 has 3, 1, 4, 1, 4. So it's actually 2 plus 3 plus 4. So assuming if it starts with 1, well, then it's going to be 2 plus 3 plus 4 plus 5 plus dot 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 9. That's going to be the number of ways that goes a peak starting with 1. 9 can go down to 8, down to 0. And then, so this is peaks. And if it's like a valley, if it goes 1 down to 0, a 0 can go up to 1 through 9. So it's 1, 2 to 9. Okay, so if it starts with 2, then 2 can go to 3, which can go down to 2, 1, 3, 2, 1 or 0. So it's 3 plus 4 plus 5 plus dot 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 plus 9. Those are the number of ways it does peaks. And then valleys, 2 can go down to 1, 1 can go up to 2 through 9, which is 8. Okay. Okay. The same pattern with 3, right? So it starts with 3. So it can go 4, 5, 6, all the way up to 9 with the number of ways to form a valley. Or if it goes down to 2, 2 can go up to 3 through 9, so that's 7 total ways. So 2 to 9 plus 9, 3 to 9 plus 8, 9. So it's the same number of numbers that are being added. 2, 3, 4, 5, 9, 9, 3, 4, 5, 9, and 9 here, and then the 8 replaces with the 2. And the next time it's this 3 is replaced with the 7. So it's like 8 plus 7 plus 4, 5. So if this is x, then this is going to be x minus 2 plus 8. And this, so that's going to be x minus, or x plus 6. And then this would be x plus 6 plus 3 minus 4, or minus 3 plus 7. So it's x plus 6 plus 4. So this total of x is x plus 10. Alright, 2, 3 is 5, 8, 7 is 15. And then that goes all the way up to, it goes from starting with 9 and go down to, you can only go downwards. So if it's starting with 9, actually technically 9 things below it. Yeah, so something like 8 plus 7, 9 down to 0, 6, 5, 4, 3, 2. Is this even bigger than the original X? It's actually smaller than the original X. It's like 9 smaller. Because 2 is replaced with, well, because this is 1 through 8 addition, and this is 2 through 9. So there's, no, it's actually 8 smaller. Each one of those digits is 1 less. X minus 8, huh? Plus 6 plus 4. X plus 6 plus 4 plus 2 plus 0 plus negative 2. X. X plus 6 plus 4. X plus 4, X plus 2, X plus 0, X minus 2, X minus 4, X minus 6, X minus 8. This is starting with 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8, and 9. So if it starts with a 1, if it goes any 3 digits, if it's 3 digits. So let's do a small computation here. So 2 through 9 is going to be the summation of that is what? 1 through 9 is going to add up to 10. I think that's 10, 20, 30, 40, 45. So it's 44. 44 plus 9 is 54. So X is 54. And then these cancel. So I have 1, 2, 3, 4, 5, 6, 7. So there's 7 X's. The plus 2 minus 2 cancels, 4 minus 4 cancels. So it's 7x. So I guess it's 8x total here, 9x total. 9x minus 8. 9x minus 8. 540 minus 54. 540 minus 50 is 490. 490 minus 4 is 486. 46 minus 8 is 478. So I think that is if num1 is between like 100 and, so I'm thinking it's a 3-digit number, so 999. See if that's right. 525. Okay, I did something wrong in the calculation. So that's 1. Okay, let's try 1 3 digits, so but starting with 1. Is that still 54? It's 53. Miscalculate this. 2 through 9 is 44. 44 plus 9 is 53. Whoops. 53 should be multiplied by 9. Unless I'm miscounting this. $53 times 9 is 5, 480 minus 3, 477, minus 8 would be 469. I'm missing something. Okay, let's try from 100 to 299. So that should be 53 times 2, 106 plus 6, so 112. 112. Okay, here's 112. Where am I screwing up this? Let's try things that start with 9. So 900 to 999. This should be 53 minus 8, so it should be 45. $45. 1, 2, 3, 4, 5, 6, 7, 8, 9. Huh. Still very confused as to why this is not 469. $525. Okay, so this was 53 correctly. Actually, x plus was it supposed to be 53? I think it was 53. So this would be 59. 200 to 299 should be 59. Okay. Should be 57 from 300 to 399. $63. Oh boy. It's x plus 6 plus 4. It's not x plus 4. Okay. Okay, x plus 6 plus 4, x plus 6 plus 4 plus 2, x plus 6 plus 4 plus 2 plus 0, plus x plus 6 plus 4 plus 2 plus 0 plus minus 2, 6, 4, 2, 0, minus 2, minus 4, minus 6, x plus 6 plus 4 plus 2 plus 0, minus 2, minus 4, minus 6, minus 8. So this eventually becomes just x minus 8. Should have been 45. And that should have been 45, which is what I got here. Yeah. Alright, so what's the calculation here? It says x plus 10. So it should be 50. I guess it'd be 59 plus 4, 63. 65. 65. 63. 59. I guess it's symmetric, right? 53 and 45. Oh boy. 50. So I would just do 53 summation to 5, difference of 4. Or maybe I do the backhand summation, 45 to 65, difference of 4. Make that times 2 minus 45. Probably the first. Actually, 53 plus 65 is going to be, I think that's the same as 59 plus 63. No, it's not. Plus 6 plus 4 plus 2. It's not linear. Oh gosh. It's quadratic, right? Is it? 6 plus 4 plus 2. Probably some sort of quadratic. Okay. Feels like this might actually be. This is like dynamic programming, maybe? Dynamic programming? Can I? Yeah, it feels like it might be dynamic programming. Although I'm kind of surprised the answer doesn't need to be in some sort of modulo, so it's kind of finite. How would I define this with dynamic programming? Like it's maybe like DP based on the number of digits. So it's like 15 is the size of the array, 15 by 10, something like that. Maybe 15 by 10 by 10. So what is the state then dealing with? The state then dealing with from one state to the next state. So is it just the current index? So like maybe the digit, the place value, or the index of the place value. Like index 0 might be the leftmost digit, or index 1 is the second leftmost digit, or index 0 could be the 1's digit, and index 1 is like the 10's digit. One of the two. And then like the current digit. The current digit and the number of number of waves at the state, number of waves up to this state, and also whether or not the last change was negative, positive, or same. Something like that. Then it has to also be bounded to, the upper bound on the number. It has to be bounded to the upper bound of the number. So how would I do that? Or maybe I don't try to handle that right now. State is the place valued digit of the index, the number of waves into now, whether or not the last change was positive, negative, or unchanged. So one goes, so the outer loop will go index by index, inner loop will go digit by digit. One, so it's 10 loops of 10, 15 loops of 15 times 10 times 10, 15 loops because there's 15 digits or indices, and then for each digit it needs to map to one of the next digits. So it's 15 times 10 times 10. Will this work? So the index doesn't have to be part of this data structure that needs to store. Is just going to be the number of waves guess the input would be, input to the state would just be the index, the digit at the index, and the output would be the number of waves. I guess it needs to include the last change as the input, if that maps to a different thing. If the index is a certain place, the digit is a certain place, and the last change is a certain thing, then that all combines the number of waves up to that point. The number of waves up to that point. Then the upper bound is going to be, how's the upper bound going to work? So if I go from, let's say x is, let's go, so intervals from 1 to 3, 3, 5, 8, 4. Three, 5, 8, 4. So I go, first digit is 1, 2, or 3. And then at 3, it needs to only go from 0 to 5. And somehow at 5 in particular, it needs to only go 5, it needs to only go from 0 to 8. 5 can only go from 0 to 8. But then if it goes like 3 to 4 to 8, how is that 8 be different than the other 8? 3 to 4 to 8 versus 3 to 5 to 8. Because the 3 to 4 to 8 can go through 0 to 9 for the next digit. But 3 to 5 to 8, that 8 can only go from 0 to 4 as the next digit. Same thing with the 3 to 1 to 8, 3 to 0 to 8. I did it as 1000. What if I did it as 1 to 9? Yes, 1 to 9 just doesn't work right. So 100 to 90, 99, 1000 to 299, something like that. And then 3000 to 3584. So 100 to 999, that's basically all 3 digits. And 1000 to 299 is all 4 digits, where first is from 1 to 2, and here maybe I decompose this thing further and go, so it's like 3000, so 3 is the first digit, followed by 4, followed by 3 other digits, where the 3 other digits are in the range of 0 to 499. So this is all 3 digits, where first is in the range of 0 to 4, and then the last one would be 500. So 3 followed by a 3-digit number here, and then 3 followed by a 5 and 2 other numbers, where the 5 and 2 other numbers needs to be from 00 to 79, all 2-digit numbers, where first is all 3 digits. So in this one in particular is all 2 digits, where the first is, but it's 2 digits. Can't really have a way with 2 digits. So maybe I need to say that this is 3, and this starts with 3 5. 3 5s, something between 0s and 7 9. Oh my god. Alright, yeah. Oh my god. So bad. So this is all 2 digits, where the first is 0 to 7. Although again, they can't form 2-digit waves. Alright, I'm just too sleepy here.